hopefully everybody can find a seat. I'm Angelo. I help organize the meetups for the AWS here in Columbus. And I just wanted to put a quick call out if there's anybody here that would like to present a future meetup, or if you have topics that you'd like us to find someone or know somebody that you think would be a good person to talk about specific topics about AWS, please reach out to me. I'll be in the back. Just come up to me and ask for a business card or give me yours, and we'll get connected and schedule you. So no more delay from that. Let's get Andrew to cover the containers for us.
Woo.
Okay, thanks for everyone for coming out. Please feel free to ask questions during this. This is really kind of an overview of a lot of services. There's quite a lot of text on some of these slides. I apologize in the back, it might be hard to read, but I'll be saying pretty much everything that's on the slides. I'll make sure the slides go out on SlideShare or somewhere like that, or on the Meetup, so that you can read through them again later. So a little bit about me. My name's Andrew May. I work here at Leading Edge. I'm the Cloud Solutions Lead and Senior Solutions Architect. I'm also an AWS Academy instructor at Columbus State Community College. Now, Leading Edge, we're a consulting company based in Columbus. We're also expanding into Nashville. We are an AWS Partner Network consulting partner. So we have a number of people who are AWS certified. And we are actually hiring people, primarily developers in the Java and .NET side, and cloud experience is definitely a benefit. Now, I mentioned that I also work for Columbus State, the AWS Academy. Well, this is sort of an arrangement between AWS and a number of community colleges where they allow us to teach kind of similar content to some of the professional courses that are offered, but at a lower price. And this is preparation for some of the different AWS certifications. So there's a Cloud Foundations course that's a 6-week course that gets you ready for the Cloud Practitioner certification. And then there's an Architect course that prepares you for the Solutions Architect Associate certification, and that's a 12-week course that builds on top of the Foundations course. There are actually some Foundations classes coming up starting in March. Registration is now open for those. There's going to be a Wednesday evening course starting March 20th downtown on the Columbus State campus. And then there's going to be one in Dublin on Saturday mornings starting March 23rd, and that's the one I'm going to be teaching. We are looking for people who are certified professionals with significant AWS experience to help teach these courses or to be involved with other initiatives that Columbus State has. So just talk to me if you're interested in that. This is kind of our overview for tonight. I mean, the broad theme here is talking about Docker containers, but there's a lot of different services within AWS that use Docker containers. So a lot of these are about running services, but there's also some service discovery aspects, particularly when we talk about things like microservices. And then there's also a few places where we use sort of Docker containers in a more transient way than a long-running service. So we're going to talk about a couple of services in AWS that make use of containers like that. This isn't an intro to Docker. I'm not going to teach you how to build Docker images or really explain what Docker is. I hope if you aren't that familiar with Docker that you read the article I sent out. However, if you want to learn more about building Docker images and best practices, there's actually going to be a Docker user group in this office space on Wednesday the 27th of March at 6 p.m. There's a tiny URL for signing up for this. I'll put that at the end of the presentation, so if you're interested in that, please go ahead and sign up for that. So just a little bit about a couple of examples of running Docker images and the difference between something that's transient and something that's a service. This is running the whale-say image, and the first thing it's going to do is it's going to download that image from Docker Hub. Now, images for Docker are composed of a series of layers, so it's downloading those separate layers, and then after they're downloaded, it will extract them and run the image. Now, this thing runs for just a few seconds, and then it exits. And then that container's completely gone. So here we're just about to finish downloading. It's a pretty large file. This layer itself is 65 meg. And then once that completes downloading, it's going to extract them all. and then finally it runs. So it runs, prints out a message, and exits. And then we run it again, and the second time it just runs for a few seconds, and it's done again. And the second time it had the image locally, so it didn't have to pull it down again, so it started much quicker. Now to contrast that, let's run Nginx. So Nginx is definitely a web server, it's a service, it's something we want to be long running. So we start this off, we're going to do a port mapping from port 8080 to port 80. And then in another tab we're going to say docker ps, and we can see that that's up and running. We're going to run a curl command to retrieve the index.html from Nginx. It gives us the HTML for that. Switch back and it logged what was, the GET request, so this is just the HTTP log. The difference here is that this is a service. This is going to keep running until someone stops this container. Now here I just manually started it. I wrote out the docker run command. It's not really what you want to do if you're running a production service, but it illustrates that difference between a transient container that just runs, does a small task, and finishes, and something that you want to keep running all the time. Now, in that first example with the whale say, we pulled that image down from Docker Hub. Now, Docker Hub has a huge selection of public images. You can have private images on there, but most of the things you pull from Docker Hub are probably going to be public images, base images like the .NET SDK or a Java set of libraries. But it's not where you put your private code that you want, your sort of corporate code. You're not going to put it in a public repo in Docker Hub. So you need a private registry. Now, Docker Hub offers you the ability to have a private registry, but so does AWS. And ECR, the Elastic Container Registry, and here's basically their quote from their marketing blurb, is just a registry within AWS. One of the big benefits of doing this within AWS is that you're storing the images close to where you're going to run them. So they have the registry in each region in AWS that supports actually the ECS service. And this means when it pulls that image down, it's local to where you're running it, and whereas you saw that whale say take 20, 30 seconds to pull down, it's going to be much quicker because it's all inside that region in AWS. Another benefit here is that these images are secured in the standard way in AWS using IAM policies. So by default, no one can access them. You have to explicitly grant the services that run these images access to the repository. Now, a bit of terminology here. This is the Elastic Container Registry, and the registry contains a repository for each image that you have. And then within that repository, you have many versions of that image potentially. So this might be every time you do a build, you push up a new version of the image. Now that can get sort of significant amount of storage, because if you have a lot of differences between your images, then it's going to push up potentially tens or hundreds of megs of changes each time. Now, due to the layered nature of Docker, some of that might be shared, but it can be a substantial amount of storage. And with ECR, the cost is all based around the amount of storage that you use. So they have something called lifecycle policies that allow it to automatically prune images that you no longer want to keep. Another thing to note when you're using ECR is that you may use the AWS command line interface to log into ECR, but what this gives you back is a Docker login. It's actually literally a Docker login command with a temporary password, and this password is basically a token that's good for 24 hours. So you need to log back in every 24 hours, or if you're doing some kind of automated build, you might as well just log in every time you're about to push an image. But after you've logged in, use the standard Docker commands for pulling and pushing images. So it's really just the authentication piece that uses the AWS command line interface. And then the image names you prefix with the ECR repository URL that contains your account ID and the region that it's in. And this is standard practice with private registries with Docker, that you prefix them with the URL for the registry, compared to something that doesn't have that prefix. It's assumed to be in Docker Hub. just a quick screenshot showing a repository with multiple versions. In this case, the versions are just numeric build numbers, and then we just tag latest as a floating tag on the latest version. Okay, so that's storing your images. Well, now let's run those images. This is where we come to orchestration. So as we saw, like running Nginx, it's great. You can run a Docker container on the command line. You can do Docker run. You can even specify some options so that if it exits, it'll automatically start again. But that's not really production ready. So you need a service that allows you to configure your Docker images and to ensure that they stay running if they're a service. So that's where Docker orchestration comes in. There's a number of things orchestration gives you. There's all this configuration. So it might be port mappings, how much CPU and memory you need, and then there's scheduling. So perhaps it runs at a particular time, or you want to run a certain number of copies, perhaps you need to run them across different availability zones. Deployment, I mean, it's great that you get your Docker image to run once, but then you've got a new version of the code base, and you want to update to that new code base without having any downtime. So you want your orchestration to manage a rolling update to deploy a new version of your code. Scaling is important. I mean, you don't want to always have to run 10 copies of your container because that's your maximum load, so you want to be able to scale up and down based upon various metrics. You might have some storage that you need to mount to your container. Depends on what your architecture is, but perhaps you need to mount some data from an EBS volume or something like that. You might have some secrets that you need to store, perhaps a connection to a database, and you want to make sure you're securely storing a username and password. High availability is obviously a key thing in everything you build in AWS. And then load balancer integration, because if you're scaling up and down dynamically, you need to ensure that those new instances of your service are automatically registered and behind a load balancer. Now, when we look at the different options within AWS, I've kind of grouped them into things that use the Elastic Container Service, things that are related to Kubernetes, and then other stuff. Now, I imagine that's probably impossible to read at the back. But there's a number of things in the Elastic Container Service, and one of them is Fargate. We'll talk about Fargate. It's really a runtime option for ECS, the Elastic Container Service. There's a couple of boxes here for Beanstalk, and we're going to talk about Beanstalk. There's two versions of Beanstalk that work completely differently under the hood. One of them uses ECS, one of them doesn't. Then on the Kubernetes side, Amazon EKS is a managed Kubernetes service within AWS that's fairly recent. And there's a grayed out Fargate box there because they've promised something comparable to Fargate with ECS, but Fargate with Kubernetes, but there's no sign of that actually appearing anytime soon. It'll make more sense once I actually talk about what Fargate is. But we'll start with talking about ECS. And honestly, this is where I have the most experience running systems in production with ECS for the last probably 4 years now. This was launched by AWS, I think, around 2015. So it's been available for a while now. So it's kind of the original. You have a question?
Are you able to control ECS and Kubernetes?
They're really sort of competitors to each other.
Okay.
Yeah. And we'll see some of the differences we talk about. So ECS is really sort of the original AWS service for running containers. There was a sort of initial version of Beanstalk that predates this. But before this was made into a public service, this was actually the background for running Lambda functions. I'm not 100% sure whether that's still the case, whether Lambda functions run in ECS. Lambda functions definitely run in containers. But this was what they did. They sort of built Lambda functions, announced it at reInvent, and they realized that the service they built to run those Lambda functions was also a service they could sell to people. Now, the ECS service itself is free. But like a lot of free services in AWS, it's only free because you can't use it without using something else that you have to pay for. So it's kind of orchestration, but you need some EC2 instances or Fargate resources to actually run your containers. This is really what they call the control plane. This is the management brain, so you don't have to pay for that portion, but you can't run containers until you actually give it some infrastructure to run it on. One of the benefits of ECS being a homegrown solution from AWS is that it's really well integrated with some other AWS services. So a couple of things in particular is it's well integrated with IAM. So one common thing is, well, I've got a whole bunch of containers running on the same EC2 instance. Some of these containers I want to have access to a particular DynamoDB table. I don't want the other containers to accidentally be able to access that DynamoDB table, but perhaps they access an S3 bucket. Well, I can use ECS to say, this container has these set of permissions and this container has these set of permissions, and it's more fine-grained than being able to apply them at an EC2 instance role level. So it gives you that more fine-grained permission management. The other big part is good integration with all the three different types of load balancers that AWS has. The classic elastic load balancers, the application load balancers, and the network load balancers. And in particular, with the application load balancers, there's some important features there. And then there's also auto-scaling of containers. I wouldn't say this is particularly advanced, but it's there, and it's serviceable, and it works in a very similar way to EC2 auto-scaling. And I don't know if you're familiar with EC2 auto-scaling, but it also gains support for the target tracking that auto-scaling got recently, where instead of having separate alarms for having to specify separate alarms for scaling up and scaling down, you can now just say, well, I want my CPU utilization to be 75% on average, and it will figure that out for you and automatically create the alarms to scale up and scale down. Now here's a picture of an ECS cluster. It's kind of a mess here. There's a lot they put on the screen. Like a lot of user interfaces in AWS, it's kind of a bit of a mess. It has evolved over time. And I've highlighted a few things here because some of the terminology is very ECS specific. You know, someone mentioned Kubernetes. Well, Kubernetes has its own set of terminology, and of course they're all different. A few things that they talk about in ECS I find kind of confusing. So ECS can either use EC2 instances or Fargate to run the Docker containers. Hopefully everyone's familiar with EC2 instances. That's just virtual machines in AWS. Now they use this terminology of container instances, and they also call them ECS instances. But that's really just referring to EC2 instances that are being registered with your ECS cluster. Basically, there's a startup hook. There's some AMIs they provide specifically for running with ECS that are cut down and just have the Docker sort of daemon on, and not a lot of the other stuff you get in the normal Amazon Linux AMIs. And at startup, you run a sort of command that says registered with this cluster, and then there's an agent that starts up and it registers with that cluster. So you can have potentially like auto-scaling groups registered with your ECS cluster. You can actually have multiple different auto-scaling groups registered with the cluster if you want a sort of non-homogeneous environment where you want a mixture of certain different instance sizes, because an auto-scaling group is going to be one instance type. But if you want to say a mixture of memory-intensive and CPU-intensive instances, you can have two auto-scaling groups registered with the same cluster. So other terminologies they use here are tasks. Now, a task is going to be one or more running containers. It has to have at least one container that's considered essential, and then you might have what you would call a sidecar. So some other container that you run alongside it that provides some other kind of utility. This could be a logging agent, it could be the X-ray daemon, something like that, but it's typically not the main part of the service. And then tasks are defined by task definitions, and then services are long-running, persistent groups of tasks, where you say, I want to run this task, I want to run 5 copies of this task. So all of these are kind of shown on that screenshot. In this example, we have 3 different services running in the same ECS cluster. It's actually just a small development cluster for an internal project here. It's running on one EC2 instance. It's by no means highly available. We've just got 1 copy of each microservice, but this is just enough for development purposes. One of the nice features here is it's pretty cost effective. We're paying nothing for ECS itself. We're paying for 1 EC2 instance, and it's a pretty small EC2 instance, and load balancer, and that's really it.
Do you think ECS is going to be free for a long time to come, or is it going to change?
I don't think they'll ever charge for ECS.
You only charge for the EC2, the
Yeah,
virtual machines.
yeah.
Okay, good, thanks.
So a little bit more about task definitions and tasks. So the definition is really the template for how it's going to run the tasks. And this is what points to the images that you're going to run. So typically those images are going to be in somewhere like ECR because it's your own code you want somewhere private. And you're going to have to give ECS permission to pull down those images. And it might have one, or in this case I've shown a task and the box has 2 different containers in it, like one of those sidecars. Now the way this works on an EC2 instance that's running the agent is the agent's talking to the ECS control plane, gets the instruction to run a copy of that task on that server because it's determined there's space there and it needs to be scheduling another instance of the task, and then the agent's going to pull down that image from ECR. It could be Docker Hub as well, but typically it's going to be ECR. Now the task definition is also where you specify all the things like what port mappings do you have, because if it's a service it's often going to expose a port or multiple ports, how much CPU and memory it needs, and the CPU and memory requirements are how ECS determines, can I fit it on this EC2 instance or this EC2 instance, or do I actually have nowhere to fit it, in which case it will just tell you, well, I can't place this task because I've got nowhere that meets my needs. And it's also where you would specify volumes and what role in IAM it's going to use. It's also where you specify whether this needs like Fargate capabilities. So we'll talk about Fargate a bit more, but that's where you're not going to be using your own EC2 instances. And then task definitions themselves are versioned. So we mentioned one of the orchestration capabilities we want is the ability to say, well, I've got a new version of my code. I want to deploy it and I want to remain up. So task definition versioning is how you do that. You create a new version of the task definition. Perhaps you just change the tag on the image that you're going to run, and then you'd say to ECS, now run this version of the task definition instead of this version that I was previously running, and it's going to do a deployment for you automatically. One of the nice features of ECS when running microservices, so you're going to run a persistent service here, it integrates well with application load balancers. Now I don't know how familiar people are with application load balancers, but they add some nice features on top of what the classic load balancers did in terms of routing requests. So an application load balancer can route requests either based on host name or path or a combination of both. So this means you can use one application load balancer in front of many different services to route requests for you. Now in this kind of fake example here, we've got an EC2 cluster running EC2 instances, and I've got 3 different services I'm running on them. Now, one of them's got 2 tasks and the other's just got one of them's got 2 containers and the other's just got a single container. All of them say, I've got something that runs on port 80. So immediately we've got a problem here. They can't all use port 80 on the EC2 instance. And in fact, none of them can use port 80 because they're not running as root. So they need to be mapped to a port on the EC2 instance. One of the nice features that they added with ECS is if you just say instance port of 0, it's going to automatically pick a random ephemeral port and then automatically map that to the target group of the load balancer. So you don't really care what that port is on the EC2 instance, as long as you give them permission for your load balancer to talk to that via a security group. It'll just register that automatically and keep the load balancer up to date as it starts and stops tasks. So that's kind of a nice integration. And in this case, we can put Route 53 in front of that, and perhaps we want to just vary the routing based upon the DNS entry, so we can just have 3 different aliases for the load balancer and route requests to different microservices. This is just a sort of a nice little, fairly simple way of routing requests to different microservices in the same ECS cluster.
Andrew, big question. What impacts this will have if you're deploying the data tier or any of the advanced services on containers on different subnets? Will it have any sort of firewall related issues if we are trying to configure NACLs? Will that be any impact?
Yeah, I mean that's a good question, and certainly if you were doing this, you would probably not put both sort of web tier microservices and internal microservices in the same load balancer. So you could, for example, have one load balancer that exposes all your publicly accessible APIs, and that load balancer would be a public load balancer. But then you could have an internal load balancer running in your private subnets that was in front of your data tier microservices, and that way then you can restrict what access and what becomes is actually public, and that gives you some control in terms of NACLs and so on. Obviously, if you're getting into random ports, it becomes a bit more complicated to control access with NACLs, and you have to expose either a range of ports. You're not required to use this auto port numbering functionality. You can specify a specific port. One of the reasons it's particularly nice is when you deploy a new version of your microservice, the default behavior of ECS is to spin up new copies before terminating the old copies. Well, if you've specified a fixed port, it can't put any of those new copies on the same servers, so you need to make sure you have more servers than you're running copies of that microservice to be able to complete the deployment. Whereas if they're using random ports, it can transiently spin up a new copy on the same server where the old copy is running before it terminates the old copy, and you can kind of get some efficiencies that way. But obviously it does mean you're exposing this wider range of ephemeral ports. Okay. One of the things that's really useful with ECS is pretty much everything can be created using CloudFormation. So if you're already using CloudFormation for your other infrastructure, you can define all the stuff you use with your microservice alongside your microservice. So you can create your IAM roles, you can create your database, S3 buckets, etc. And you can also create your tasks, your task definitions, your services, your scaling policies, all in the same set of templates. So you're not mixing and matching technologies to be able to stand up your microservices. Now
I'm sorry, what's a cloud formation?
So CloudFormation is AWS's infrastructure as code language. So it's their own custom thing. Terraform's kind of a competitor to that, that's multiple clouds, but it's, in theory, it has better support for AWS resources than Terraform. There are times when CloudFormation support lags behind actual sort of technology updates, and it can be frustrating when that happens. I know they recently added support in ECS for being able to map secrets into your container from AWS Parameter Store, and that came out a couple of months ago, and we're still waiting for the CloudFormation support for that, which is frustrating because we're actually making use of Parameter Store, and we have to have another mechanism to suck those values into our containers. But it is generally a benefit that you can stand up a CloudFormation stack and have your services running alongside all the other things you find in CloudFormation. When you update a service, and this could be either using CloudFormation or using the API calls, and say, I want this service to use this new version of the task definition, it's going to do a blue-green deployment. So it's going to start up your new copies of your service, check that they're healthy. So typically you're going to define an application load balancer, health check URL, and it's going to make a call to that, and it'll say something like, well, call every 10 seconds and wait for 2 successful calls before I consider this instance healthy. It's going to do that on the new instances before it starts to think about terminating the old ones. So that means your service remains always available. There's always going to be instances of your task registered with your load balancer and serving requests. And if for any reason those new containers don't successfully start and pass their health check, it's just going to keep running the old version of the service. So you don't have an outage if for some reason you started pushing out a container that doesn't even start. So that can be pretty useful. There's some ability when you're running on EC2 instances to specify task placement. And that's particularly useful if you want to make sure, well, I'm running 3 copies of this service, I want you to absolutely make sure you run those across different availability zones, because if there's an issue with an availability zone or an EC2 instance in an availability zone, I want to make sure I've got copies running elsewhere. But you can also do the opposite and say, please bin pack, shove as many containers into as few EC2 instances as possible because I want to save money. So you've got different options there in task placement. And this can be useful when it comes to non-homogeneous clusters. And I think you can use this with GPU support. So if you have containers that need GPU support, you could have perhaps some of your instances in the cluster with GPUs attached and say, well, I need this container to run on a instance that has a GPU attached and not elsewhere. There's the idea of Daemon Services, and these can be used for running agents like the X-ray agent for collecting tracing metadata. And those will run one copy on each EC2 instance in the cluster. That way you don't have to include it alongside each task as a sidecar. So if you imagine I've got a fairly large EC2 instance, I might run 10 different tasks on there, but you don't want to be running 10 copies of the same agent unnecessarily on there. So that's one way you can do that. And then metrics from ECS go to CloudWatch, as pretty much all other AWS services do, and logs can go to CloudWatch logs or other destinations.
Can you talk a little bit more about if you have instant fleets and ECS infrastructure, would you be able to use like node labels or something to pin containers to particular fleets? Like you mentioned GPU.
I've not used it a great deal. I know there's definitely a bunch of sort of tagging support, so you can say, well, I need it to be this instance type, like if you've got CPU, sort of like C4s or C5s or something, alongside M types or some memory, sort of high memory instances. There are a bunch of different rules that it does support, and I think some of them are just general tagging rules, so you could say run on instances that have this tag, and other ones for availability zones. But I don't know, honestly, every option for that because I've not used much more than the sort of make sure you spread across availability zones. That's the one I've mostly used. So Fargate's a different option than using EC2. And it actually simplifies a lot of things because we get away from having to manage our own EC2 instances. So think of this as the air quotes serverless option for running containers in AWS. Now, obviously nothing's serverless, there's a server somewhere. But all you have to do is specify, I want this container to have this much CPU and memory with particular limits. There's sort of, basically it's a graduated scale, like you can say I want this many CPU units and 512 is half a CPU. I'm not sure what half a CPU looks like. And then there's particularly memory configurations for each CPU allocation. So it's not like an infinite scale. You have to pick particular categories. But you'll get then guaranteed to have that much CPU allocation and memory allocation for that particular task. This is different than when you run on an EC2 instance because they're all sort of kind of sharing resources then to a certain extent. Memory allocations can be fairly strict, but CPU allocations are kind of a bit sort of loose. So if you have one container on an EC2 instance that's using a lot of CPU, then it may somewhat dominate other containers on that same EC2 instance. This does mean, in the case of EC2, you can actually sort of over-provision, which can be useful from a cost basis. If you've got a bunch of microservices that aren't used a great deal, you can shove a lot of them onto the same instance, because most of the time they're not being hit that often. Whereas with Fargate, you're paying for that much CPU availability all the time, whether that particular service is using it or not, and there's no sharing between your different tasks that are running.
So Andrew, do you know when Fargate got into AWS? 5 years ago? 10
It's
years
not
ago?
that many years. It's been perhaps 3 years.
3 years.
Something
I
like
know
that.
Azure is doing something similar, but only 3 years. Okay, thanks.
Yeah.
And that must be very little usage comparatively now to the EC2 side, right? Okay.
Yeah, it's been around long enough that it's been somewhat adopted. And for the reasons I'll show on the next slide, it's probably getting more popular now. So the configuration you define very similar to with using EC2. You still use task definitions. There's just a few things you have to specify differently to be able to run on Fargate. One important difference is that the networking is always what they call AWS Vpc. So Docker has different networking modes that are kind of standard to Docker. The AWS Vpc mode is kind of specific to AWS. And it basically means it uses an elastic network interface per container or per task, I think it's for the collection of containers. And so it's using up one of your subnet IP addresses. Now this means you're directly addressing that container, so it has some benefits in some ways, but it also means you have to keep more of an eye on the number of IP addresses you allocate to your subnets. You can use AWS VPC networking with EC2 instances, but because each container requires an elastic network interface, and a lot of the smaller instance types have very low limits for the number of ENIs you can attach, it's not very useful. Now, we no longer have any kind of a shared server, so the concept of a daemon service, as we talked about for running something like the X-ray daemon, doesn't exist anymore. So if you need to run something like what you would have run on as a daemon on EC2, you now have to run that as a sidecar, so there is some extra overhead there, particularly in memory utilization. One of the areas Fargate really does help is scaling is now, it's still at the task level, but when you were running it on top of EC2 instances, well, yeah, it's great to say, well, I can scale up to 10 copies of this microservice. Well, you have to make sure you've got enough memory and CPU available on your EC2 instances in your cluster to be able to spin up those 5 extra copies of the container. And that means you need to have your EC2 instances scaling based upon how many containers you're running. And there are ways you can do that using ECS metrics, but it's not instantaneous. And getting the maths right so that it scales up and down when you want it to, and you don't over-provision or under-provision your EC2 instances can be difficult. And that's why it's a lot easier with Fargate, because it just pretty much scales infinitely. You can just spin up as many as you like in Fargate. It's going to cost you, but you don't have to worry about provisioning extra EC2 instances. Now, cost is where Fargate falls down traditionally. Sorry, go ahead.
Sorry. If you're running inside a custom VPC, definitely registering and deregistering ENIs is time consuming.
Sure.
How does it affect scaling when Fargate is scaling up or down? Because it has to register ENIs and deregister it, the scaling down. Does that affect the time of scaling up and scaling down respectively?
Yeah, I mean, it's definitely going to. It's going to be very similar to the problem of running Lambda functions within a VPC, that you see that extra startup time and the extra teardown time in particular. I'm not sure in terms of cost with Fargate how much you end up still paying for the time that the ENI is hanging around, whether it's the same with Lambda functions. I know it can take a long time for it to clean up the ENIs. I don't know whether that's really an issue with Fargate. I've not used it a great deal, primarily for this reason that it's been rather cost prohibitive up to now. I still think you're going to find it's a lot faster to start a Fargate task and obtain an ENI than it is to spin up another EC2 instance in an auto-scaling group, have that registered with the cluster, and then receive containers. And it's definitely easier to manage. But I'm not sure, whether there is a point where you find, well, the scaling is limited by how fast it can allocate ENIs. So that's a good question. So pricing has been, a sticky point for Fargate since it was launched. Part of the reason for this is when AWS introduced it, they said they wanted to make sure that they weren't risking any crossover between different customers. So they never ran containers from different customers in Fargate on the same EC2 instance, because they wanted to guarantee that sort of separation, that there couldn't be any leakage of IAM permissions between those containers. So if you ran one container in Fargate, behind the scenes somewhere there was an entire EC2 instance running that one container for you, and no other customers would be on that EC2 instance. Which meant they priced it accordingly to assume that some of these EC2 instances would be sat there half empty. Now, if you're running multiple containers in Fargate, they'd all, some of them would go in that same instance, but I assume they provide some cross-AZ availability, so it's still like a bit cost ineffective. So what they announced at the last reInvent was they created something called Firecracker. It's sort of a new lightweight virtualization, And this has allowed them to provide the level of isolation that they got from those separate EC2 instances with much smaller virtual machines that are very quick to start. And this allowed them to do some significant cost savings. Some of the Fargate sizes reduced as much as 50% in cost, so it's a really big change. You're paying by sort of virtual CPU hour and memory per gigabyte hour, and it's still expensive compared to a well-utilized EC2 instance. It really comes down to, are your EC2 instances well-utilized in your ECS cluster? Because depending on exactly how many you've got running and how much cross-availability zone availability you want, you can find that they're not well-populated, and Fargate may actually now be cheaper. And there was an analysis here, and if you are interested in this, if you get a copy of the slides, you'll be able to follow this link. But they found that with the price reductions, Fargate's about the same cost as a 70% utilized EC2 instance, which was better than it was, which was around sort of 40%. Now, if you reserve EC2 instances, you get a big cost saving. But if you're scaling up, typically you would pay you would reserve your baseline, and you might not reserve what you need for the scaling out, so it gets a bit more complicated. But Fargate's definitely worth a second look if previously you'd avoided it because of the cost. Okay, so moving over to the whole other side, the Kubernetes world. The well, it's not actually the Elastic Kubernetes service, I wish it was. It's the Amazon Elastic Container Service for Kubernetes, henceforth known as EKS, which in theory makes it easy to deploy Kubernetes in AWS. I say in theory because it's a pretty new service and there's definitely some teething issues, and it's gone through quite a few evolutions in its early stages where how you actually set it up has changed quite a lot. Now, Kubernetes, if you're not familiar, is really the predominant Docker orchestration engine or service across all the cloud platforms. I think at the time ECS came out, Kubernetes was definitely a thing, but there were a lot more competitors that people weren't quite sure who was going to win. And you can kind of see why AWS may have decided, well, let's just create our own, then we'll have full control of it. We can integrate it with our own services. But now the writing's on the wall, and all of the cloud platforms now have managed Kubernetes services. The Google service, because Google came up with Kubernetes, is by far and away the most mature of these. The Azure option, the Azure Kubernetes service, came out just before EKS came out. They both came out last year. I would say in terms of maturity, my feeling is that the Amazon is the least mature of these three. I get the impression that Azure have worked, the Microsoft team has been much more involved with the Kubernetes development. They actually have been in charge of some of the recent Kubernetes releases instead of Google. So they've been much more involved with Kubernetes development than Amazon have. Now, you've been able to run Kubernetes on EC2 for a long time, and people have been doing that. A large number of Kubernetes deployments have been on EC2 instances in AWS for a long time before EKS. And there is support in the Kubernetes core code for various different AWS services like Elastic Load Balancers and mounting EBS volumes as volumes within Kubernetes. So EKS is really just building upon some of that support that was already there. Sip of water before I completely lose my voice. This is a problem when I'm teaching at Columbus State, because I'm usually talking for about 2 hours then. So it's a managed service, but what's it managing?
Don't you already have some sort of orchestration with the ECS?
Yeah, and this is an alternative. It's a more industry standard type of orchestration, but they're filling very similar roles. So they're competitors to each other. But AWS is at least giving you a choice of which one you use. So EKS is managing what they call the Kubernetes master nodes here. In AWS's case, they're running 3 of these master instances. And these master instances are responsible for things like scheduling and configuration management and various things like that. And they take that away, so you don't have to set those instances up, which can be kind of complicated. But you have to run these other instances. Here they're labeled as Kubernetes minions. They tend to call them for EKS node instances. So you're going to pay for those EC2 instances, similar to an ECS cluster, but they're going to manage this control plane for you. Now it's at the bottom of the slide here, but actually one of the big differences from ECS is EKS, the control plane is not free. It's 20 cents an hour, and that doesn't sound like a lot when you talk about an hour, but it's $140 a month, which is fine for an enterprise. But if you're a hobbyist and you want to start playing around with Kubernetes, you may shy away from this implementation because that's quite a lot for a personal bill. And I really wish, I mean, AWS have said how highly available their implementation is because it's potentially more highly available than Google's implementation or Azure's implementation, but there's no choice about it. You get that whether you need it or not. So if you're a hobbyist, really you'd probably be happy with one master instance instead of 3, and a third of the cost. But unfortunately, that's the only choice you get. Now you can automate the creation of your cluster here with CloudFormation, and they've been sort of evolving this over time. There's been several different versions of their CloudFormation templates for doing this. And they actually just launched a quick start for Kubernetes in the last few days, or they just announced it in the last few days, to make it easier to spin up a cluster. But it's still more involved than ECS typically. I think they recommend that you may have a separate VPC, although you can reuse an existing VPC. You need a service role because the EKS cluster itself is going to be doing things like creating load balancers on your behalf, whereas with ECS, you would typically create the load balancer via your CloudFormation and then let sort of ECS integrate with it. Here, EKS is going to create new load balancers itself. You create the cluster and then those node instances. Unlike ECS, they provide a custom EMI that bootstraps and registers with the cluster. The big difference here is at this point, you've got no applications. And when you want to deploy applications to Kubernetes, you have to switch over to using the standard Kubernetes tools. So this is the kube control command line interface and YAML templates for deploying Kubernetes applications. And yes, this is the standard way. So if you're familiar with Kubernetes, either on-premise or on other cloud providers, there's some standardization there, but it does mean it's not all in the same tool. So you're going to stand up your cluster in one way, but then deploy your applications in a different way. Now, the quick start they have uses a rather involved process where I think you can put your YAML templates for Kubernetes in an S3 bucket, and it uses a Lambda function to deploy them to the cluster when your cluster starts up. But that seems a bit sort of root type, involved to do that. And as I said, it can be kind of pricey. A few other things that, this is going to sound like a downer on EKS, and honestly, I'm sure it's a great service in many ways, but it's definitely a much steeper learning curve and much more work to get to the point of integration with other AWS services than ECS is. So if you want to integrate with some of these different AWS services, there's a lot more work that you have to do. So Kubernetes, as I mentioned, already had support for some of these AWS services, but like classic load balancers, but not application load balancers. So if you want application load balancer support, you'll have to bring in something like the AWS ALB ingress controller. That's another package you have to install. If you want to integrate with IAM at the pod level, and a pod's basically the same as a task in ECS, so it's a collection of one or more containers. If you want that to have IAM permissions, then you need to install something called kube2IAM. If you want your load balancers that are automatically created by Kubernetes, when you say this service has type load balancer, it'll spin up one of those classic load balancers for you. Well, perhaps you want that registered in Route 53. Well, you have to install external DNS for that to happen. If you want your logs accessible outside your Kubernetes cluster, you have to install something like FluentD or another logging agent to pick the logs up from the cluster. And if you want your metrics outside the cluster, you need something else, and there's a bunch of different options there, and they've changed over time with Kubernetes. And to install those, you might need to install Helm before you can install those other services. And one of the gotchas here is all those things you're installing are running containers on your EC2 instances. So again, going back to sort of the developer who's trying to just try out Kubernetes, well, you can only run so many containers on a T2 instance. You may find you've used up most of those slots just with these other services that you need to run in your Kubernetes cluster to integrate better with AWS. So, there's definitely some configuration setup that you need to do with a new EKS cluster. Once you've got it all set up, then you're fine and good to go. But getting it set up and figuring out all these things you need to know about, these third-party tools that you need to be aware of, is definitely more work than ECS. Now, one of the big sort of benefits of Kubernetes is that standardization across cloud platforms. You can take basically the same YAML template and run the same service across multiple cloud providers in their managed Kubernetes solutions, and even locally on something like Minikube. But there is significant differences. If you spin up a managed cluster in 3 big cloud environments, what's pre-installed in terms of services is significantly different. So you need to understand those differences if you're going to move an application between those cloud providers. And the way a lot of this is achieved, if you say, well, I want to spin up a load balancer, but I want my load balancer in AWS to put its logs into S3 so that I can collect those logs and look at them. Well, you have to add an annotation into your template. And annotations are basically like something that says, in AWS, if I'm running in AWS, do this, but ignore if I'm on any other platform. That's great. You can have annotations for all 3 different cloud platforms in the same template, but it can make your templates kind of cluttered. But at the end of the day, your service itself probably won't know the difference between which cloud platform it's on, and that really is where you get that benefit of cloud portability, but a lot of that's just because it's a Docker container and not because it's Kubernetes. So, I don't think EKS is necessarily a bad service. I think its ease of use is definitely, it's more difficult to start using and integrate with other AWS services than ECS is. And if your use case is fairly straightforward and you don't need some of the more sophisticated features that Kubernetes has, ECS is probably a better place to start. Now I'm going to mention Elastic Beanstalk, more for completeness than anything, because it is an option for running containers in AWS. Now, if you're not aware, Elastic Beanstalk's really a platform as a service. The idea is it makes it easy for you to bring your existing applications into AWS without really having to know much about AWS. It manages all the underlying infrastructure. A lot of the times, what you'll see is it actually creates a CloudFormation stack and launches some EC2 instances and the load balancer, and you can look at all the infrastructure it creates for you. And it manages things like high availability if you want, and deployments, and collecting logs. So it can be useful when you're getting started with AWS, but you are sort of basically hiding away the details of the real underlying infrastructure. There's 2 versions. And actually, the first version of Elastic Beanstalk container support predated ECS. It allowed you to deploy a single container at a time with a particular Elastic Beanstalk service, and each container would be on a separate EC2 instance. So that's not a very efficient use of EC2 instances to just run one single container. It also installed Nginx as a proxy. But the only interesting feature of this was it could take your source code and your Docker file and build the container for you before deploying it. Now, multiple container support, where you could run multiple containers on the same EC2 instance, came about in 2015, and coincidentally, this is just after ECS launched, and wouldn't you know it, behind the scenes, it uses ECS. In this case, it can now only reference pre-built Docker containers. The reality is, if you're going to use ECS behind the scenes, you should probably just use ECS directly and understand how it works and get the best value and have the most options for configuring it. There may be some small benefits for Beanstalk, especially for things like taking a web application in a language like Java and just shoving it into Elastic Beanstalk and it'll run it. But for containers, I would probably stay away from Elastic Beanstalk. But you will see it listed as one of the options for containers in AWS, so I wanted to at least mention what it could do.
So would you recommend Electric Beanstalk for proof of concept and ECS for production-ready services?
With Docker containers, I would probably say skip Beanstalk entirely. I'd say if you're coming from, say, a Java shop and you have a web archive and you want to just deploy that in Tomcat, then sure, go ahead with Beanstalk as your starting point. But for something like Docker, I really don't think there's any great benefit to using a Beanstalk. Perhaps if you already were familiar with Beanstalk commands and its tools, then perhaps it might be easier. But if you've never used Beanstalk before, you're just learning one set of commands when you could be learning the ECS commands that are probably just as easy to learn. Okay, so those are the orchestration options that we're going to talk about. So the next category of things I want to talk about are a bit sort of more related to service discovery. Let's assume we're running some microservices in containers. So Cloud Map is a cloud resource discovery service. Now, Cloud Map, and I'm sure you can't read that there, started out as something called Service Discovery for ECS. So it started out as an ECS-specific tool, and it basically took ECS instances that were running with that AWS VPC that we mentioned Fargate uses, where the containers get their own IP address, and it put records into Route 53 in a namespace, basically a hosted zone, and it created A records and service records for them. And then you could query DNS and say, well, what copies of service A are running? And then at runtime, you could make the decision of, well, I'm going to pick that first record returned by DNS. And that way, you would always know exactly what was available just by doing a DNS lookup every time you're about to make a call. Now, obviously, it relies on making DNS queries, and it could only really support things that could go into DNS. And it had to use that AWS VPC networking, which, as I've mentioned before, pretty much really just works with Fargate, so you're incurring that Fargate overhead cost-wise. Now, Cloud Map, they took that and they said, well, let's make this a more general service, and let's not just limit it to DNS-based lookups. Let's put an API on here, and then we can put things in Cloud Map that don't really make any sense in DNS. So what's the DNS entry for a Lambda function? Or what's the DNS entry for an SQS queue? Well, there really isn't one. So the API allows you to put things in there that don't really, that can be sort of, can be a DNS queue, an SQS queue or a Lambda function. And it can also be different versions of a Lambda function. It could be a particular alias of it, and you could look it up in particular ways and get back different versions of that Lambda function. It still integrates with ECS, and it also integrates with EKS, and they made it transparent, so if you're already using the service discovery for ECS, you suddenly had Cloud Map. Now, really where this is competing is it's very similar to HashiCorp Console. And the reason you might use this rather than Console is they're doing the management plane, again, this control plane portion. You're not paying for that in particular. There's some costs per service, but you don't have to manage setting up a bunch of EC2 instances to manage a console cluster. They're doing all of that for you. You just have to turn it on and make some API calls, and suddenly it's there. Now, they sort of talk about why you might do this in terms of comparing a static mapping versus a dynamic mapping. So here we've got a front-end service calling a back-end service, and we've got version 1 and version 2 of the back-end service. Now, perhaps these are running in parallel, and they have different DNS entries for version 1 and version 2. Well, if you want to switch a service from talking to from version 1 to version 2, you have to make a configuration change and probably restart in the traditional way without Cloud Map or without some similar service. With Cloud Map, you're going to do that lookup dynamically before you call it, and then you can switch that alias effectively in Cloud Map to point to version 2 instead of version 1, and it just switches over, and the next time it makes a call, it's going to call version 2 instead of version 1. And you didn't have to make any changes at all to the front-end service to be able to do that. And this extends much beyond microservices.
Is that a bastardized version of Kubernetes service lately?
Well, I mean, it's serving a similar role, and like I mentioned, it's similar to Console, and there's other services like that provide, similar capabilities. Now, I mean, the difference here is that it's obviously going across different resources across the AWS spectrum of services. So this rather contrived example they show here has a Kubernetes cluster calling an ECS cluster, calling a Lambda function that calls S3, that also calls an auto-scaling group and an RDS database. Now, you probably would never have that combination of services, but they're all just registered in CloudMap with these different aliases, and they can all be looked up and registered in CloudMap. And it gives you that kind of dynamic ability to switch what you're talking to. And there's various sort of tagging strategies you can use here so that the lookups can pick different versions of different services. So an example they give is, well, perhaps you've got two different S3 buckets, and based upon how you look up that bucket in CloudMap, it will give you the different bucket back. Now, in a similar idea or related idea is Cloud Mesh, or App Mesh, which is really sort of a service mesh for AWS. Now, service meshes are the new hotness in the microservice world. Probably the biggest one is Istio, and this is really AWS's entry into that area. Now it's in beta, and it's nowhere near done. They've kind of launched it as a public preview. You can install this and you can run the parts of it that exist now. Certainly not production ready. I don't know at what point it will become a fully fledged service, but it's interesting that they're getting into this realm. So the way this works is they're using the open source Envoy proxy, which is, I think, the same thing used by Istio. And this runs in front of your containers. All traffic that goes to your container and all traffic coming out of your container goes through the proxy. And this means the mesh can take control of a lot of the things that you might have previously done within your application itself. So service discovery is obviously something we talked about CloudMap. Well, CloudMap requires that your application is changed to be doing those dynamic lookups, whether it's in DNS or calling that API to find the version of the service it should be calling. Here, you let the proxy do all that for you. You just say, I want to call this service, and the proxy is the one that knows about the different instances of that are available and dynamically decides where that request goes. This allows it to do a variety of traffic shaping things like A/B testing. It also kind of makes the Envoy proxy your load balancer. You don't need to go through a separate load balancer. And it can do interesting things like handling failures with retry capabilities or circuit breakers. And that, those are big topics in the microservice world, but typically you might be integrating those into your microservice. Here you don't need to do that anymore because the service mesh takes care of that for you. Now they plan to integrate logging and CloudWatch metrics and tracing with X-Ray into AppMesh. None of that's there yet, so this is why I'm saying it's a very early stage with this. They have some of the basic traffic routing portions of this available. Certainly something to pay attention to, but if you want a service mesh now, this is not your answer, but it will, I'm sure, be a sort of a much bigger service in the coming years. Just some diagrams about how it dynamically routes requests between different instances of services. That's not particularly interesting. Now finally, and I'm losing my voice just as well, a couple of different services that use containers in a slightly different way. So most of what we've been talking about so far are persistent services, microservices typically. Here, batch is a completely different way of using containers. AWS Batch is designed to run thousands of batch jobs sort of efficiently on AWS. And it makes use of containers under the hood. So here, a job is a unit of work. It might be a shell script, it might be a Linux executable, or you might directly specify a Docker container. At the end of the day, it's going to run in a Docker container. And behind the hood, it actually uses ECS. So they have a job definition, and a job definition is an IAM role and some CPU and memory requirements. Well, that's basically a task definition from ECS. And then you have queues of jobs, and that schedules where the jobs are going to run, and then they run on EC2 instances. Now, one of the features of this that makes it low cost is you can use spot instances. Now, you can use spot instances with ECS anyway, but this is really designed for running with spot instances to get the lowest possible cost, because it's a batch process. You don't necessarily care when it's going to finish. So you can tolerate the sort of the unavailability that you might get from spot instances. And then finally, code build. So a completely different usage of Docker is using Docker to build other applications. Now, what you build here might be a Docker image, or it might be something else. It might be a Java application, a .NET Core application, or C, or Go, or whatever it might be. But Code Build's AWS's managed continuous integration service. Now, by itself, it's pretty primitive. It's really generally combined with Code Pipeline, and the two together make for a bit more of a complete system, and then you might have Code Commit as your Git repository, and some other tools at the end of the pipeline to actually do your deployments. But Code Build just kind of that bit in the middle that's going to build your code and run your tests in a Docker container. You can either use Docker containers that they provide that have some common build tools pre-installed, or you can create your own images and put them in ECR or pull them from Docker Hub. There is actually support for Windows builds here using Windows containers, so you can build .NET Framework applications. Under the hood, it's using a Windows server there. It's a bit more expensive to do these Windows builds because it has to provision larger EC2 instances behind the scene. The nice thing about this is it scales automatically based upon the submitted jobs you have. So you're no longer managing in the traditional sense of, I need to spin up this many agents and pay for those EC2 instances. All you pay for here is the build minutes. And the build minutes, you get 100 free every month, and that's not just a free tier thing. So it's certainly something if you're just building your own personal project in AWS, this can be a good option because 100 build minutes may be enough for all you're doing personally. Okay. Well, that's kind of a review. It's not too in-depth, I know, but of a lot of the different services related to containers in AWS, so if anyone has any questions.
For the EKS, that you kind of not that super compared to Google Cloud and the Microsoft Azure. So those, they have sort of the equivalent of the EKS using Kubernetes, but they're a lot more mature. But are you aware of those two platforms? Do they have their own, like the, whatever that one here, EWS?
ECS.
Do they have something their own, or they directly went to Kubernetes?
Google, because they created Kubernetes, it's really the only option in Google Cloud.
I didn't know that, now I know. Okay, good.
Azure had their own Kubernetes and still has their own, has Kubernetes service, but has their own container service that predates the Azure Kubernetes service. So you do have choices in Azure over which one you use. I think they perhaps more push the Kubernetes. I think their original container platform was less mature than ECS possibly. I haven't used Azure a great deal, but that's the sort of impression I get. So I think Kubernetes might be more your best choice in Azure than it is in AWS, where I think it's much more of a, you've got to decide whether you really want to be running Kubernetes. Good. I think if you had a choice of cloud platforms and you wanted to run Kubernetes for sure, you would probably pick Google.
I see.
Obviously, it depends on the other services you want to run alongside it, but it's definitely the most preferred.
Inside Amazon, inside AWS, the container side of the business is still very small, 10% of the whole AWS, or maybe even smaller than that. Container, is the place I work. We didn't even touch cloud, even less of containers. So the AWS container is still teeny tiny.
Relatively speaking, I mean, a lot of places are still running things on virtual machines, just straight up on EC2.
Yeah.
But if you count everyone who's using Lambda functions, whether it's their application running Lambda functions or just Glue for ETL or infrastructure creation, those are all running containers. So actually the usage of containers is much higher than you might initially think.
That's your perspective on that. Okay, good, thanks.
Would you please give us some guidance on the comparing serverless to containers? So, if you're comfortable building a serverless app with Lambda functions, step functions, and all the ways that Amazon lets you kind of like trigger other things through Lambda and other services and daisy chain them together, and then to use things like DynamoDB and Aurora for your persistence. what kinds of apps would you build for a container, especially since the serverless is evolving so rapidly? Is it like websites that you run on?
Yeah, I think it's a balance. I mean, a lot of my experience has been building, traditional web applications, back-end services. Depends on what your needs are, and certainly you can mix and match depending on what's the most useful for a particular microservice. So you don't have to say, everything I'm going to do is container-based, or everything I'm going to do is going to be serverless. You may decide that particular services have particular latency requirements and always have to be available and highly responsive, and that you get that better out of a container than you might do with Lambda functions. Now, Lambda functions can scale almost infinitely, but every time they scale up, you've got a cold start of a new container.
Right.
And that can be pretty painful, especially depending what language it is. That's why languages like Go are so popular in the Lambda space, because it's got a great startup speed and also a great runtime speed. Things like Node and Python start quickly on Lambda functions, but they don't run as well continuously. But Java and to some extent .NET Core have a very painful cold startup on Lambda, and it can take 15, 20 seconds on that first invocation for them to successfully complete that first request. And that is something that people aren't always going to tolerate with a service.
Okay.
There's the other thing where sometimes you have a collection of a lot of different APIs, and they may not be all invoked very frequently, but depending on how you manage your Lambda functions, if you say every different URL path or every different get or post or delete is a separate Lambda function, and you put that behind API gateway, that can be a huge collection of Lambda functions, and managing all of those and deploying all of those can be a lot more complicated than a single container that just contains all of those together. So as a unit of deployment, it can be much easier for services with a lot of different endpoints. Now, there's techniques where people will basically do all the routing within a single Lambda function, but that seems to be somewhat of an abuse of the idea of a Lambda function. But I think people, it partly depends on your background and the size of the project you're working on, but there's definitely room for both. A lot of what I've done has been containers for the core services and Lambda functions for things that wrap around them, particularly asynchronous processing.
Thank you.
We use ECS for production deployments.
Yeah.
One of the things we always struggle with is local development, because obviously if you want to do anything local testing, it's difficult with those kind of things. We end up using Docker Compose and the other things that are provided with Docker itself, and at that point you've got to manage different configuration files to be able to do that. And if you had any luck in terms of kind of balancing that out philosophically in terms of how you do local development but still be able to do production deployments using some kind of common deployment platform like ECS?
Yeah, I mean, I've actually worked in a couple of different places where...
Could you repeat the question, please?
It's basically how you balance local development with a service like ECS, where there's no local ECS version that you can run, and how you use tools like Docker Compose or not to sort of get the same capabilities for testing. And what we've done, a couple of different clients, I mean, we've taken two different approaches. The client I'm at the moment, so far we've mostly been taking that Docker Compose approach, where if we want to run an integration test, perhaps it's that service plus a database, we'll just spin that up in Docker Compose. We can easily spin up a new database, it's almost instantaneous, which is definitely not in AWS if you're spinning up something in RDS. That can take 20, 30 minutes. Whereas it can start in seconds in a Docker Compose locally, and then we can run some tests and tear that down. And that's certainly useful for sort of integration on a single service level. The problem with Docker Compose is once you start having multiple services and you want them to talk to each other and you want to test that, then it gets very complicated. One of the benefits of Kubernetes is there are local versions of Kubernetes you can run. However, the challenge there is often there's bits of Kubernetes they don't support. If you're using something like Minikube for Kubernetes locally, there's all types of things you can't do in it that you would do in a cloud provider, but it's closer to what you could do in a cloud provider. The other approach we've taken is, well, if all your infrastructure's in ECS, just have the developers spin up your CloudFormation stacks and run it possibly in a separate account, or possibly just parallel stacks in your development account, just running all those containers or a subset of those containers in AWS, and that's how you test it. You do all your development locally, but if you want to actually test how the containers run, there's no substitute for running them in AWS. Now that can be pricey. If you have a lot of developers running a lot of stacks, and they stand them up at the start of the day, and perhaps they tear them down at the end of the day, or perhaps you automate that because you're sick of telling them to tear down their stacks, not speaking from experience at all, then you may find that your development bill is far more than your production bill. True story. But perhaps that's the best solution, because it gives you that flexibility to say, I want to run this version of this service and this version of this service alongside all that other AWS infrastructure. Perhaps you're doing some Lambda functions, perhaps you've got a set of step functions that you really can't run anywhere else. And it is the most consistent and most reliable way to be able to say, I tested it in AWS and it works. Where then you can have confidence moving it between your environments. Whereas if you run it in Docker Compose, or even if it's the Kubernetes, if you run it in Minikube, it's still not the same as running it within that cloud provider. So I think at some point you've got to bite the bullet and say, as soon as possible, run it on the real infrastructure. But there's definitely costs involved in doing that.
Yeah, we started looking at local stack, which seems to simulate AWS thing. It seems like it's sort of a hacky solution. Surprisingly, it works a fair amount, but you just don't know how much it can simulate everything that AWS has to offer.
That's often the problem with these. I think I was recently looking for some way of simulating S3, and because we were trying to do particular things with KMS keys and our S3 bucket, that just didn't happen to be there with any of the mock S3 implementations. So it's like, well, I guess we're just going to have to talk to a real S3 bucket from our integration tests in a test account and just accept that. But yeah, I mean, it's one of the challenges with a lot of AWS tools is there is no local equivalent. They've got better with Lambda functions. You can run local versions of your Lambda functions these days, and you could never do that before, but it's still a challenge. Thanks.
How do you do that local mock with a Lambda if you're using Daemons?
That's a very good question. I'm not sure what it really supports. I've personally not done a great deal of that. I know they have the serviceless application model and the SAM local, and that's the way that it'll pull down Docker images that are equivalent to what they run in Lambda. But the limits of that is when you start integrating with other AWS services, there's a limit to how much it can actually simulate any of that, and you do tend to end up still calling other AWS services, whether it's an S3 bucket or a DynamoDB table. Well, Dynamo you can run locally, but some of these other services you can't.
Always looking to do it local.
Sure.
It's just a huge challenge when you have to do with things with KMS and like
Sure.
for example,
Yeah.
anything with an S3 or a Lambda or even EC2. It's almost worth it just to do it straight up in an AWS and leave the local behind.
Yeah.
And of course, it does drive your development costs, and maybe that's the new normal. And that's
perhaps it is, yeah. I mean, it's interesting, yeah, when your bill comes in and development's always more than production. That's a strange world, but that may be the world if you've got lots of developers using AWS infrastructure. Question back?
Can you talk about some options to increase persistent volumes in either ECS or EKS? Are there any options?
To increase
persistent volume, like PVCs, persistent storage.
Okay. Honestly, it's not an area I'm very qualified to talk about because I've not used a lot of persistent volumes with Docker containers. A lot of what I've done in the microservice world has been backed by databases or Dynamo and other stores like that, so we've not been directly mapping storage to our containers. I've done a little bit of it with EKS and mapping EBS to, there's a standard way of handling volumes in Kubernetes, and that supports EBS, and obviously there you can specify the different EBS classes, whether they're provisioned IOPS and so on.
Run out of EBS storage, then what?
Are you talking about EFS, using EFS?
I need some kind of persistent storage. GlusterF has something that I can configure with my Kubernetes cluster. And what are my options for either of?
Yeah, I mean, I'm sure, I mean, with the nature of Kubernetes, I'm sure someone is probably working on some open source project to take some of these new file systems they've launched, like the Lustre, SFX, and so on, to integrate those into Kubernetes as a storage option. And that is one of the benefits of the Kubernetes platform, is that there's more flexibility for people to come in and build integrations, whereas ECS is very much a closed platform. So at one point they had like a scheduling project where people could build custom schedulers for ECS, and that completely died. It was an open source project, but it never even had an initial release. Whereas with Kubernetes, there is definitely that ecosystem of people saying, well, I want to be able to use this other external service with Kubernetes and map it into this standard Kubernetes concept like a storage volume. So that someone may be out there doing that. It's unlikely to be AWS though. It's going to be someone else in your position who says, I really need this. I'm just going to go ahead and implement it because I'm not going to sit here waiting for AWS to do it, unfortunately.
Thank you.
Yeah, go ahead.
You mentioned an interesting comment about containers. One advantage of containers is that they're compatible across cloud platforms.
Yeah.
And, and that just led me to think, we've always been comfortable investing in AWS for years.
Yeah.
Because they innovate at light speed and, they're the leader and they still are the leader. Are you seeing people, where they want to write things and that are cross-platform, where they want to keep that in mind, where they're hesitant to invest in one platform?
Definitely a lot of organizations, especially when they first go to the cloud, they'll often say, we want to keep cloud portability in mind. That doesn't mean they're ever going to change clouds, although they might do. One of our clients is now considering moving from AWS to Azure, and the reason there is a lot of companies don't want to do, like if you have clients, often your clients don't want to do any business with Amazon because Amazon's a competitor to so many companies that a lot of companies are hesitant to be giving any money to AWS indirectly via their vendors. So some companies are saying, well, I like everything AWS offers, but some of my clients won't let me use it. So I'm going to look, perhaps I'll use it now, but perhaps I'll hedge my bets and say, I want to be cloud agnostic. The reality is none of these solutions are cloud agnostic, but you can architect your applications so that you have very clear boundaries of what's cloud specific and what's not. And containers are definitely one of those tools where you can say, my configuration for this container is I pass in some environment variables, and that could come from ECS, it could come from Kubernetes, or it could come from something in Azure or Google Cloud Platform. It doesn't really care. It's got this consistent base of what's installed inside that container. I can run it locally, I can run it in the cloud. So it gives them that portability. Now, obviously, if the code inside is calling the AWS SDK and talking to a DynamoDB table, then suddenly you've lost all of that. Yeah. But if you architect your application inside your container to say, well, I'll put that portion behind a generic interface and say, well, I'm going to call a NoSQL database. It just happens to be Dynamo in this current implementation, but I know I can rip out that portion of code and switch it for Mongo or something, then you've got some of that portability, or at least you have some idea about your dependencies on your particular cloud platform. I do see, there's always news stories when a big company moves between different cloud providers. Perhaps they're moving to AWS or off AWS. I certainly hear a lot of people say Google Cloud Platform is considerably cheaper than the other options. But if you look at the list of services available in Google, it's a much smaller list than Azure or Amazon. So I think it depends on your needs. And that's where some people are going to say, I'm going to run all in Kubernetes, and if I need a Mongo database, I'm going to run that in Kubernetes. I'm not going to run it some external managed service. I'm going to put more and more things inside that Kubernetes platform, because then I'm not really tied to anything outside of my Kubernetes cluster, and if there's a service that Google's lacking, I just run it in my cluster. But, Amazon has that huge list of services, and Azure has a huge list of services, and they perhaps are better in some areas, and they've obviously got integrations, Office 365, App Dynamics, all these other things, but then Amazon's got its own specialities. So I think it's still it's a balance between exactly what you're looking for in a cloud provider.
And many large enterprises are trying to be vendor agnostic, unless you're going to a SaaS.
Yeah.
Whole different story.
I think the reality is that's often what they say up front. The more you get into developing, you find the convenience of the managed solutions is such that you start to rely on them for better or worse. It saves you time in development, but there is that sort of hook that they've now got you in that it's more work to move on.
Does both ECS and EKS support Windows Containment?
I don't think either do at the moment. Now I mentioned Code Build does, so I think there's definitely some work with Windows containers. I think if you're going to run Windows containers, you're probably stuck with Azure now to have, robust support for it. I think it will come in time, but with .NET Core, there's less of a drive to need Windows containers because you can now use .NET, .NET and run it in Linux, and it works pretty well. I mean, the current project I'm on is all .NET Core based. So.
And does ECS support service mesh like HGST? I know Kubernetes has inbuilt support for that integrates with HTTP, but ECS?
No, not at the moment. That's where that app mesh product that's in beta would come in. That would be the service mesh that would run both inside EKS and ECS. So they've obviously seen that that's a gap. They don't have anything equivalent to these service mesh architectures. So that's why they're trying to build their own. But yeah, you could probably run that in EKS, but you couldn't in ECS at the moment.
One more question. Is there any real benefit of using EKS instead of other services like KOps or KubeSpray to run?
I've not had a lot of experience, but obviously those tools have existed for running Kubernetes in AWS for some time. They're typically more mature because they've been around, but EKS obviously has the weight of Amazon behind it, and they're going to keep evolving that. They can optimize sort of for high availability in ways that some of these third parties may not be able to. And while that $140 a month may sound expensive to a sort of individual developer, it may be cheaper than running the equivalent 3 master nodes for yourself in a high availability setup using one of those other tools.
So Andrew, I'm not sure it's a question to you. Whoever was introducing you, so this is the first. So is this a cloud user group, or is this only for AWS?
This is AWS specific.
This is only AWS specific. Are you aware of other Google or Azure?
There are different meetups for those.
Good, good.
The Azure one meets at the Microsoft offices, and that's pretty much every month.
Okay.
The Google one is very occasional, it seems.
Oh, that's not much.
Yeah.
That sounds Google is not a whole lot of people using it. Just kidding.
I don't know. The local group doesn't seem very active. The Azure one's pretty active, and
Azure is good. Okay.
I would say their meetup, they only ever tell you what the topic is about the day before. They'll announce there's going to be a meetup, but they never tell you what the topic is the day before, and it's always on a Monday, so unless you're watching over the weekend, you're not going to know whether you want to sign up for it.
Actually, the reason I'm asking is like this gentleman, you guys have been doing this AWS thing for years. The place I work, we just started talking about moving to cloud and not a whole lot going on. And I was talking to a colleague from Nationwide the other day. For us, the only thing we run out is the Office 365, talking about it. Well, that's behind it's Azure. So I'm just thinking about, how come that, just people like, are you a small company? Very small. Okay, how many people here are like Nationwide or Chase already have 50% of their whole application running in the cloud already? No. Okay, thank you so much. Only Office 365 or Workday or something like that, right? Okay, thank you. I don't want to get upset.
I mean, if you're a financial company or a healthcare company, they're really scared about putting those private information. Security,
yeah.
So even though it might be, some people would say it's more secure on the cloud, they can't really explain why, so like the regulators.
You explain, because I'm working for a healthcare company, that's where. So we're that lady from Chemical Action, or actually Brian Hill? He's out. So is chemical abstract already 50% cloud or?
It's not 50%. We are just using for data analytics and machine learning.
I'm sorry?
We are only using for data analytics and machine
You're
learning.
only for cloud for native machine learning or AI or something. Okay.
Yeah, not for processing. We are only
Not
using
for
it-
your core kind of thing like
Yeah,
your.
we're storing it as backup, any of the contents in S3, that's all.
I think you'll find
good,
that
good. Thanks.
the larger organizations are probably going to be the slowest to move a large proportion to the cloud. A lot of the time it's going to be smaller organizations who have a smaller footprint that they can move.
Yeah, absolutely.
Yeah.
I mean, if you're in healthcare, you might want to look into private cloud.
Private
Maybe
cloud.
Cloud Foundry or Azure gives you a private solution.
Yeah.
I don't know if does AWS.
They announced some kind of more support for sort of private cloud things you can run locally.
I know before they were like, no, we're all public.
Yeah. And if any of you are interested in the Columbus Docker user group, this is pretty much a new user group. Because the old one kind of stopped meeting. There's going to be a meeting for that on March 27th, talking about building images and tips and tips and tricks.
Is that on Meetup?
It's not on Meetup, it's on Eventbrite at the moment.
Eventbrite.
That's why there's a tiny URL there, because otherwise you probably won't find it.
So this is your last slide. If we allow us to get your presentation,
Yeah.
we should proceed.
You should be able to see that, yeah.
Okay.
But I'll leave it on the screen there for anyone who's interested.
So they are going to take.
I'm not presenting this, but someone from Leading Edge is going to present it, who's got more Docker experience than I have. Well, thanks everyone for coming.
Anyone wants to take a pizza home? We have plenty back here.
Yeah, you did pretty much most of the